Forget prompt engineering. Loop engineering is here, the death of the oracle. Look at your YouTube feed, your Twitter, your LinkedIn. Every AI guru is still selling the same outdated lie. Master these 5 secret prompts to unlock GPT-5. How to write the perfect 500-word instruction to get exactly what you want. Let's be brutally honest. Prompt engineering is dying. In fact, treating an LLM like an oracle where you type a magical sentence, pray to the GPU gods, and hope a flawless answer pops out, that entire paradigm is obsolete. Prompt engineering was the skill of talking to AI. The next era isn't about talking to AI, it's about managing AI workers. Welcome to the discipline of loop engineering. Right now, the smartest engineering teams on Earth aren't sitting around tweaking adjectives in a system prompt. They are wrapping frontier models, whether it's Claude, Gemini, GPT-5, or DeepSeek, inside automated, self-correcting control systems. Because today's models are no longer just answering questions. They are executing multi-step autonomous workflows. They aren't chatbots anymore. They are digital employees. And if you don't learn how to build the loops they live in, you're going to get left behind. The paradigm shift. From chatbot to employee. To understand why this matters, we have to look at the fundamental flaw of standard LLMs. The traditional AI experience looks like this. Human, prompt, answer. You give it a task, it gives you a response. If the response is wrong, you have to read it. You have to find the mistake, and you have to write a follow-up prompt to fix it. You are the control loop. You are doing the heavy lifting, babysitting a chatbot. Loop engineering flips this entirely. The new paradigm is human, goal, AI agent, verify, improve, repeat, deliver. Instead of asking the model to be perfect on the first try, you accept that it's going to mess up. You expect it to hallucinate. You assume it will make mistakes, but instead of a human catching those mistakes, the software architecture catches them. Think about how a real human software engineer works. If I ask a senior developer to build a new feature, they don't just type out the code blindly from top to bottom, close their eyes, and push it directly to production. No, they think about the architecture. They plan the modules. They write the code. Then they run it. They look at the error logs. They realize they missed an import statement. They fix it. They run the tests again. And they repeat that loop until the feature actually works. Loop engineering is the science of building that exact cognitive loop around an AI model. The AI becomes a self-improving worker. Anatomy of an agentic loop. So what does a loop actually look like under the hood? Let's deconstruct the anatomy of a modern agentic system. It usually follows a continuous cycle. 1. The goal. The human inputs a high-level objective. Not an instruction, but an outcome. E.g., find a vulnerability in this codebase and patch it. 2. Gather context. The system looks at its environment. 3. Plan. The model breaks the massive goal into 5 or 10 microtasks. 4. Execute. It uses a tool like a browser, a terminal, or an API to perform the first task. 5. Evaluate. This is the magic step. The system evaluates the output of its own action against the goal. 6. Fix mistakes. If the evaluation fails, it reflects on why it failed, updates its plan, and tries a different approach. 7. Store memory. It notes what worked and what didn't, so it doesn't repeat the mistake. 8. Repeat. It spins through this cycle dozens, sometimes hundreds of times, until the success criteria are met. Track tree, real-world dominance, where loops matter. Let's look at how this changes the real world, because this isn't theoretical. This is how production-grade AI is being built right now across major industries. 1. Software engineering. In the old days of prompt engineering, which was, let's be honest, last year, you'd type, "Write me a Python script to scrape this website." The AI would output a wall of text. You'd copy-paste it, run it, hit an error, copy the error, paste it back to the AI, and repeat. With loop engineering, the architecture behind tools like Claude Code or Devon, the agent is the developer. You give it the goal. The agent designs the architecture, writes the code, spins up a local terminal, runs the tests, reads the error logs, fixes its own syntax errors, refactors the code for performance, benchmarks it, and automatically commits the clean code to GitHub. You just watch the logs fly by. Chapter 2. Cybersecurity. Imagine an AI security agent. It doesn't just read code and flag potential issues. In a loop, the agent scans your infrastructure, detects a vulnerability, writes a script to verify if that vulnerability is actually exploitable, generates a patch, deploys the patch to a staging environment, reruns the exploit to ensure the patch worked, and then hands you a finalized security report. 3. Deep research. A traditional search prompt gives you a summary of a few web pages. A research agent operating in a loop reads the initial papers, identifies gaps or contradictions in the data, realizes it needs more evidence, searches again with a completely different query, downloads the raw PDFs, cross-references the citations, and builds a comprehensive verified dossier. If the evidence is weak, the loop keeps spinning until it finds the truth. The dark side, the cost of the loop. Now, let's strip away the hype. Loop engineering sounds like magic, but in production, it is a brutal engineering challenge. There are major bottlenecks and risks that nobody making flashy demo videos wants to talk about. First, the token tax is real. When a model is constantly planning, executing, evaluating, and reflecting, it consumes an immense amount of compute. A single task that used to cost fractions of a cent in a standard chat window can easily cost $10, $20, or $50 in API fees when an agent runs through 100 iterations in a complex environment. Second, there is the infinite loop trap. If your evaluation logic isn't incredibly robust, an agent can get stuck. It will try a task, fail, modify the prompt slightly, try again, fail the exact same way, and keep burning your money until you manually kill the process. Third, state drift. As an agent loops over and over, its context window fills up with its own history. If it spends 40 iterations failing, its memory is now cluttered with 40 examples of bad code and mistakes. The model actually starts to degrade in real time because it gets confused by its own messy history. Managing, pruning, and summarizing that memory layer is where true engineering skill is required. The new skill of the future. This is why the entire conversation around AI talent is shifting. The industry is moving from single model intelligence to systems intelligence. We are no longer asking, which model scored 2% higher on a standardized benchmark? Instead, organizations are asking, how well does this system plan? How effectively can it use tools without breaking them? Does it have the capacity to verify its own work? Can it recover from an unexpected failure, or does it just collapse? If you are a software developer, an AI engineer, a DevOps specialist, or a technical product manager, this is your new roadmap. Frameworks like LangGraph, CrewAI, AutoGen, and the OpenAI Agents SDK are becoming the standard infrastructure for software development. The takeaway is simple. Prompt engineering was about crafting better instructions. Workflow engineering was about connecting static steps. Loop engineering is about building autonomous systems that can think, act, fail, learn, and succeed on their own. Stop trying to write the perfect prompt. Start building the perfect loop. Use a female transatlantic voice for the narrator.